Right then, question set 13 for our do now today. You've got 5 minutes. Have a go at everything, please. And what was I going to say? Oh, yes, you got 5 minutes starting now. Cool. Right, so 5 minutes are up. So write down the next two terms in each sequence. Well, what's happening on here? We're adding 7 every time. Add 7, add 7. So we're going to add 7 again to get the next number, which is 37. And then add 7 again to get the next number, which is 44. And we keep adding 7 to get the next ones. Let's do a little pen change. This one, what's happening from one term to the next? This time we're actually subtracting something. We're taking away 4. So every time we take away 4. So we're going to take away another 4 here to get 9. And take away another 4 to get 5. And we keep doing that to continue the sequence. Right? So 9 and 5 are the next two. Then, what have we got here? Write down the first 8 prime numbers. The prime numbers are the numbers which have exactly 2 factors. That means they can only be divided by 2 things. And those 2 things are 1 and itself. So if you can divide it by anything else, it's not a prime number. So for example, 20, I can divide it by 1 or 20, but I can also divide it by 2 or 4 or 5. So that's not a prime number. What about 18? Well, again, I could divide that by 2 or 9 or 3. So that's not a prime number. The prime numbers actually start with 2. That's the first one. 1 is not a prime number. And the next one is 3. And then 5. And then 7. And then 9. No, it's not 9. Because 9 you could divide by 3. So that's not a prime number, is it? Okay. So the next one's actually 11. How many do we need? 8. 1, 2, 3, 4, 5. Okay, next one is 13. So that's 6. And then 7. After that, we go to 17 is the next one that can't be divided by anything else except 1 and 17. And then after that, 19. So there are the first 8 prime numbers. 2, 3, 5, 7, 11, 13, 17, and 19. And they go on forever, actually. There's an infinite amount of them. Right, write down the nth term. Now, if you didn't get this one, just watch closely. It's a bit like the first ones when it first starts. What I'm actually looking for is what is happening from one term to the next. Am I adding or subtracting? Well, I'm adding 5. In fact, every step is adding 5. So I write 5n, because look, we're after the nth term. This nth term, that's what it said in the question, so 5n. Whatever it's going up in or down in, put that with n. Now that would make the 5 times table. We have to do a little adjustment here. We imagine that we're going backwards through our sequence. What would the number before be? All right. Actually, if I do going along here, look, I'm going down in 5s. Take away 5. Take away 5. Take away 5 again. The next number would be -2. So I put that on the end, and that is the nth term. All right. Let's neaten up that 2. That's rubbish. So 5n minus 2, and that's it. It's a bit like the 5n. This is like the 5 times table, except it's not, is it? It's all been shifted 2 less than the 5 times table, which is why it's 5n minus 2. But the main step is find out what it's going along in, and then find out what the previous term in the sequence would have been if it was there. Now this one's going up in 3s. So every time we're adding 3, let's try and actually write some 3s there. So we put 3n. Now if I was going backwards through my sequence, what would the next number be? I'd be taking away 3, wouldn't I? 10, 7, take away another 3 to get 4. And that's an ordinary positive 4. So it's 3n plus 4. It's like the 3 times table, but 4 more than that. Every number is the 3 times table, just plus 4. Okay, well done. Off to your main task then. Bye-bye.